In 1942, amidst the turmoil of World War II, a group of American mechanics stumbled upon a piece of aviation history that would change everything: a downed Japanese Zero. As they meticulously disassembled the aircraft, what they uncovered went far beyond technical specifications. They unearthed a secret that would reshape their understanding of enemy capabilities and tactics. While some characters in this narrative may be fictionalized, the story is firmly rooted in real events that highlight the ingenuity and resolve of those who faced the Axis powers. Join us as we explore this captivating moment in history, where every bolt and rivet tells a tale of bravery and unexpected revelations. Subscribe to our channel for a deeper dive into history's lesser-known stories. Gain access to well-researched facts, rare perspectives, and clear explanations that bring the past to life. With regular uploads, you'll stay informed and inspired by the resilience of those who shaped our world. Don't miss out. Join our community today. On a sun-baked day in September 1942, beneath the sprawling canvas of a makeshift hangar at Pearl Harbor, American mechanics gathered to scrutinize the remnants of a Japanese Zero, one of the most advanced fighter aircraft of its time. Having been shot down in a skirmish over the Pacific, the plane had landed in the hands of American forces, an unexpected trophy that promised invaluable insights into enemy technology. As the mechanics disassembled the aircraft, their curiosity transformed into a meticulous examination of its design, revealing features that challenged the conventional wisdom of warfare and engineering in the early 1940s. The Zero, known formally as the Mitsubishi A6M, embodied Japan's commitment to lightweight, agile aircraft capable of dominating the skies. The mechanics, led by Chief Warrant Officer Edward "Eddie" McAllister, were seasoned veterans who had witnessed the rapid evolution of military aircraft. As they unscrewed panels and lifted components, the hidden intricacies of the Zero's construction began to emerge. The aircraft's fuselage was built of a thin layer of duralumin, a lightweight aluminum alloy that was both strong and malleable, allowing for greater maneuverability. This choice of materials contrasted sharply with the heavier, more robust designs favored by American engineers, reflecting a philosophical divide regarding aerial combat. As the team delved deeper into the aircraft's systems, they stumbled upon the Zero's unique engine, an exceptional Nakajima Sakai that bristled with innovation. The engine's simplicity belied its power. It was a marvel of engineering that allowed the Zero to climb faster and turn more sharply than its American counterparts. Observing the intricate craftsmanship, McAllister noted the precision with which the engine had been assembled, a testament to Japanese industrial efficiency. His admiration was tinged with concern, for it was clear that this technological edge had significant implications for the ongoing conflict in the Pacific. During their examination, the mechanics noted the Zero's armament system, which was deceptively minimal compared to other fighters. With only two 7.mm machine guns and two 20mm cannons, it seemed insufficient for a dogfight against heavily armed American planes. However, the Zero's design philosophy prioritized speed and agility over sheer firepower, allowing it to outmaneuver and outsmart its opponents. This revelation led to discussions among the team, sparking debates about the future of aerial tactics and the necessity of re-evaluating American strategies. The delicate balance between brute force and agile precision emerged as a central theme in their conversations, a reflection of the broader strategic dilemmas faced by both sides in the war. As evening fell, the mechanics gathered around a small table cluttered with notes and diagrams, their minds racing with possibilities. They realized that the Zero's design was not merely a product of Japanese ingenuity, but also a symbol of their national ethos, encapsulating principles of efficiency, adaptability, and a relentless pursuit of excellence. Each component of the aircraft seemed to tell a story, woven together by the spirit of a nation determined to assert itself on the global stage. In this moment, the mechanics felt a compelling urge to understand not only their enemy's technology, but the culture that birthed it. In a surprising twist, McAllister uncovered a series of handwritten documents hidden within the fuselage, written in a clear yet hurried script. As he carefully unfolded the fragile papers, he recognized them as technical notes detailing modifications made to the initial design of the Zero. These notes revealed both the creativity and desperation of Japanese engineers as they adapted their strategies in response to battlefield realities. Each notation hinted at attempts to maximize performance under constraints, reflecting a mindset shaped by the crucible of conflict and a determination to innovate amidst adversity. The mechanics gathered around to study the documents, which appeared to include instructions for emerging technologies not yet widely adopted. Speculation arose regarding the potential of jet propulsion and other advanced systems that could redefine air combat. It struck them that these insights were not just reflections of Japanese ingenuity, they were warnings. McAllister, sensing the gravity of the find, urged his team to compile their findings into a report that could be shared with higher command, a document that could alter the fabric of American air strategy. As the night deepened, the men contemplated the implications of their discovery. Each realization bore the weight of a dual narrative: the resolve of American forces to overcome their adversaries, and the intricate dance of innovation that defined modern warfare. The Zero served as a mirror, reflecting the essence of both nations' ethos. It was not simply an enemy aircraft, but a canvas against which the art of war was being painted. The mechanics found themselves at a crossroads, conscious of their role in a larger historical moment, one that extended beyond the confines of their hangar. The sun would rise on a new day, illuminating a world where the past and future collided within the remnants of a downed plane, revealing the secrets that lay buried in the ambitions and efforts of two nations at war. With their tools still in hand and a sense of purpose rekindled, they prepared to take these revelations into a broader arena, fully aware of the stakes. The Zero was no longer just a prize of war. It was a herald of change, a testament to the relentless pursuit of progress, and a reminder of the intricate human spirit that fueled conflict and innovation alike. Each piece extracted and analyzed would serve as a building block toward understanding and ultimately, in this turbulent era, a path to victory. As the sun rose over the sprawling expanse of the Pacific Theater, tensions simmered beneath the surface of the American military base on Guadalcanal. Following the downing of an elusive Mitsubishi A6M-0, the mechanics, largely composed of young men raised in the heartland of America, were about to embark on a journey that would reshape their understanding of air warfare. The Zero, a symbol of Japanese aerial superiority, had become not just a target in the skies, but an enigma on the ground. The sight of it, mangled and damaged, invoked a mix of dread and fascination. Each mechanic, clutching tools in hands calloused from a life of labor, felt the weight of history resting upon their shoulders as they began to disassemble the machine. As the first panel was removed, both the meticulous craftsmanship of the Japanese engineers and the crude expectations of their American counterparts came to light. The Zero's fuselage, constructed with a lightweight alloy, was a marvel of engineering, starkly contrasting with the heavier components typical of American designs. The mechanics exchanged glances filled with disbelief and admiration. It was as if they were peering into the future. A mixture of pride and competitive spirit ignited within them, revealing a deep-seated desire to understand and ultimately overcome this adversary, who had so astutely adapted to the demands of aerial combat. Amidst the disassembly, the mechanics discovered an intricate web of wiring and systems that indicated not merely a design for speed and agility, but also a profound understanding of aerodynamics and engineering principles. Each detail, from the design of the flaps to the arrangement of fuel lines, told a story of innovation driven by necessity. The Zero was not just a fighter plane. It was a testament to the resilience of Japanese ingenuity, forged in a nation that had faced its own challenges. The mechanics began documenting their findings, taking notes that would soon ripple through the ranks of the American military and create a new lexicon of engineering. One particular element caught their attention: the Zero's unique engine, a Nakajima Sakai, was equipped with a supercharger that allowed it to maintain power even at high altitudes. This revelation sparked a series of discussions among the mechanics, who could not help but draw comparisons to their own aircraft, the F-4F Wildcat. The realization that the enemy had designed a system to exploit the very limits of atmospheric physics sent waves of urgency through the group. If they were to develop an effective countermeasure, they would have to delve deeper into the Zero's wings and guts, dissecting the innovations that had allowed it to dominate the skies. As the days turned into a whirlwind of work, camaraderie blossomed amid the intense scrutiny of the disassembled aircraft. Stories of home and dreams for the future filled the air, intertwining with the smell of grease and metal. They bonded over the challenges of their unique task, forging friendships that would sustain them through the harrowing experiences of war. This sense of unity resonated with the spirit of a nation grappling with its identity and purpose in a world at war. The mechanics, now more than just soldiers, felt as though they were pioneers on the frontier of a new kind of warfare, and their mission transcended the immediate task at hand. The culmination of their efforts came on a fateful afternoon when they uncovered a section of the wing, housing a series of unexpected modifications. Hidden within the structure was a series of adjustments that hinted at an emerging philosophy in Japanese aviation strategy, a commitment to adaptability and evolution in combat. The mechanics realized that the Zero was not merely a static weapon. It was a reflection of a strategic mindset that embraced innovation as a means of survival. This idea, a narrative thread in the broader tapestry of the conflict, connected the dots between the technological advancements and the shifting tide of war. News of their findings rapidly circulated throughout the ranks, reaching high command and igniting debates among officers and engineers alike. The implications extended beyond a simple analysis of an enemy craft. They symbolized an urgent call to action, pushing American forces to reconsider their approach to air combat. As discussions grew heated, the mechanics felt a mix of pride and trepidation. Their discoveries were no longer just technical insights, but pivotal pieces in the greater strategy that would determine the outcome of the war. Yet, beneath the surface of this newfound knowledge lay a haunting realization. The Zero was not merely a tool of war. It was a manifestation of the human spirit, a relentless drive to innovate and assert one's existence. The mechanics grappled with the implications of their work, recognizing that their adversary was not only a foe to be defeated, but a testament to a shared humanity, one that operated in the shadow of survival and conflict. This revelation subtly shifted their perspectives, causing them to approach the war not merely as combatants, but as participants in a broader historical narrative, one shaped by struggle, resilience, and the pursuit of excellence. As the disassembly progressed, the mechanics engaged not only with the aircraft, but also with each other, their interactions a microcosm of the larger ideological battle unfolding across the globe. They were crafting not just a response to an urgent military need, but a deeper understanding of what it meant to confront an enemy that was equally committed to its cause. In the heart of the Pacific, Amidst grease-stained overalls and the clatter of tools, a new chapter was being written in the annals of history, one that would not only alter the course of aviation, but reshape the very essence of American identity in the face of adversity. In the summer of 1942, as the sun cast long shadows across the tarmac of the United States Naval Air Station at Pearl Harbor, a group of American mechanics stood transfixed before the disassembled hull of a captured A-6M0. The aircraft, once a potent symbol of Japanese aerial supremacy, lay in fragments, its once sleek contours stripped of their mystique. What had begun as a routine examination of enemy technology had morphed into a profound inquiry into not only the material of warfare, but the ideas that fueled it. Each mechanic brought their expertise to the task, but it was the unexpected nuances of the Zero's design that seemed to beckon them into deeper contemplation. Among those mechanics was Master Sergeant Jack Sullivan, a veteran of the Battle of Midway, who had spent countless hours in the hangars of the Pacific tending to PBY Catalinas and F-4F Wildcats. Jack's hands were calloused, a testament to years of grappling with engines and airframes, yet they trembled slightly as he navigated the intricacies of the Zero's construction. Unlike the robust and heavy designs typically favored by American engineers, the Zero was constructed with an astonishing combination of lightweight materials and ingenuity that seemed almost futuristic. It was as though he held the remnants of an advanced civilization, prompting him to wonder about the minds that conceived such a craft. The mechanics unearthed startling features that highlighted the Zero's superiority. The aircraft's wings displayed a careful tapering, a design that allowed for superior lift-to-drag ratios. Its powerful engine, a Nakajima Sakai, offered remarkable agility despite its modest output when compared to American counterparts. Sullivan marveled at the meticulous attention to weight distribution, which contributed to its exceptional maneuverability. This was not simply a machine, but an embodiment of a philosophy, of speed and grace over sheer firepower. The implications of this became clear to the team. As they surveyed the Zero, it was clear that American aviation design was still shackled to the pragmatism of the past, while the enemy had embraced a bolder, more innovative spirit. As the week wore on, the mechanics shared whispered conversations in the late-night glow of the hangar lights. Fragments of their discussions floated in the air, punctuated by the sharp scent of aviation fuel and the distant rumble of aircraft engines. They debated the cultural ethos behind the several design choices and the implications of what they were discovering. "Maybe they're onto something," Sullivan suggested, gesturing towards the Zero's audacious approach to engineering. The others nodded, slowly realizing that this craft represented not just a threat, but a challenge, a mirror reflecting their own limitations and complacency. In the midst of these reflections, an unexpected discovery emerged. While combing through the cockpit, Sullivan stumbled upon a series of markings, symbols and annotations that appeared to blend Japanese kanji with what resembled Western engineering notations. This hybrid writing spoke of exchanges between cultures, of ideas that transcended national boundaries, revealing a surprising interconnectedness in a time of fierce division. It suggested that even in wartime, creativity could flourish in collaboration, challenging the narrative of the isolated genius and the notion that ideas could only arise from one cultural milieu. The team gathered around as Sullivan shared his find, the air thickening with a sense of urgency and anticipation. The markings were more than just technical annotations. They suggested a convergence of knowledge streams that had been developing for decades. It implied a lineage of thought that included influences from American engineering practices, perhaps even tacit lessons learned from previous conflicts. This realization hit hard. Were they not also capable of such ingenuity, of bridging divides to create something greater? The Zero had to be seen not merely as an adversary, but as a provocative challenge that could galvanize American innovation towards newfound heights. In the following weeks, the mechanics began to synthesize their own observations with local engineering teams, sketching out ideas that had been sparked by the Zero. They intuitively began to pursue their own experiments, merging aspects of Japanese design with American engineering principles, challenging the pervasive belief that victory in war could only be achieved through numbers and brute force. They wrestled with the desire for efficiency and the need for creativity, realizing that true progress might require the blending of these seemingly contradictory ideas into a cohesive strategy. As they presented their findings to higher command, they wove a narrative that was both compelling and unsettling. The Zero had inadvertently become a catalyst for transformation, illuminating a path forward that was steeped in humility and open-mindedness. Sullivan looked around the room filled with brass and officers, observing their raised eyebrows and thoughtful expressions. This was a moment of reckoning, not merely for the mechanics, but for the entire military establishment, caught in the web of its own assumptions about warfare and creativity. The path forward would not be easy. As they prepared for subsequent battles, the implications of the Zero's design bore heavy on their shoulders. The mechanics understood that the lessons learned were not just about replicating a successful model, but about fostering an environment conducive to innovation and questioning established norms. The Japanese Zero, once a weapon of war, had become a key to unlocking a future that had been previously unimagined. As Sullivan and his team labored under the glow of the hangar lights, they were no longer merely engineers. They were pioneers, on the cusp of redefining the very nature of aerial combat, one inspired revelation at a time. As the sun rose over the Pacific Naval Air Station in San Diego, the atmosphere buzzed with a strange combination of excitement and anxiety. American mechanics, their hands stained with grease and streaked with sweat, circled the disassembled remains of the beloved enemy aircraft, the Mitsubishi A6M0. Each mechanic brought a different skill to the table, their collective expertise honed through years of aircraft maintenance and military construction. They had been tasked with an unprecedented mission, understanding the secrets of this formidable fighter that had wreaked havoc on American forces less than a year earlier at Pearl Harbor. Now, as they pored over the aircraft's components, they were poised to unveil knowledge that would alter the course of the war. Among the team was Chief Mechanic James "Jimmy" O'Reilly, a man known for both his technical insight and his penchant for storytelling. O'Reilly gathered his crew around the fuselage, pointing out the Zero's unique design features, from its lightweight construction to the innovative engine placement. "This baby is like a dancer," he remarked, emphasizing the maneuverability that had allowed the Zero to outmatch American aircraft in dogfights. The mechanics listened intently, their fascination evident. With every bolt removed and every panel lifted, they discovered not just the ingenuity of Japanese engineering, but the sacrifices made in the name of speed and performance. It was a bitter pill to swallow, realizing that the enemy had been so advanced. As they scrutinized the Zero's construction, one mechanic, a young and eager technician named Tom Bennett, stumbled upon an unexpected discovery. Hidden beneath the cockpit, he uncovered a set of documents, their edges frayed and faded from time. With trembling hands, he handed them to O'Reilly, who carefully unfolded the papers. They contained detailed notes on the Zero's design philosophy, along with specifications that hinted at future iterations of the aircraft. "This isn't just a fighter, it's a blueprint for evolution," O'Reilly said, a sense of awe creeping into his voice. The revelation echoed through the group, transforming their initial task into something far more significant, an opportunity to understand the enemy's mind and anticipate their moves. The implications of their find extended beyond mere technical advantages. As the days turned into weeks, the mechanics absorbed the intricacies of the Zero's design, allowing them to innovate on their own aircraft. Inspired by the blueprints, they began modifying existing planes, incorporating lighter materials and re-engineering the design for improved agility. O'Reilly, who had once viewed the Zero as an insurmountable adversary, now felt a stirring sense of hope. Each modification was a testament to American resilience, a subtle yet powerful reminder that the tide of war could be influenced by intellect and adaptation rather than sheer force alone. Yet even as the mechanics celebrated these discoveries, the shadow of the conflict loomed large. The knowledge they uncovered was a double-edged sword. Each improvement made to the American fleet had to be executed with precision and urgency, for the stakes were high. German and Japanese forces were not idly waiting. They were refining their strategies, learning from mistakes and growing in strength. Amid the clamor of engines and the scent of oil, worry began to infiltrate conversations, igniting debates about the war front and the lives at stake. The mechanics understood that their work could potentially alter the fate of missions, and with it, the lives of countless soldiers. To keep morale high amidst the pressure, the team often shared stories from home, painting vivid pictures of their lives before the war. As they engaged in these exchanges, they forged bonds that transcended their original roles, transforming them into a family united by a common purpose. They laughed over shared meals and supported one another through moments of frustration. It was during these discussions that they not only repaired aircraft, but also nurtured the very spirit that would fuel their resilience against the relentless tide of war. However, as their newfound sense of community flourished, each mechanic was silently haunted by the reality of their efforts. The war was not just an abstract concept, its brutality manifested in real lives. Each plane repaired and each idea conceptualized could mean the difference between life and death for their comrades in the Pacific. The burden of this knowledge weighed heavily on O'Reilly, who often found himself reflecting on the cost of victory. The aircraft they worked on would be piloted by young men like them, and the thought of their potential sacrifice filled him with an unsettling mix of pride and fear. One evening, O'Reilly gathered his crew under the stars, illuminating the night with a flickering lantern. "We're not just building machines, we're crafting hope," he declared, his voice steady. "Each of you is a part of something greater than ourselves." Beneath the vast canopy of the Pacific sky, the mechanics absorbed their leader's words. They were not just assembling hardware, they were participating in an unfolding narrative, one that would resonate through history. Bound by their shared experiences, they understood that the secrets of the Zero had not only unveiled a path to combat readiness, but had also awakened a profound sense of purpose within each of them. The journey they embarked upon was as much about engineering as it was about the human spirit's capacity to adapt, survive, and ultimately triumph against the odds. As the American mechanics gathered around the disassembled fragments of the A6M0, the air was thick with intrigue and the scent of machine oil, mingling with the lighter notes of sweat and determination. Each piece they scrutinized was a testament to the ingenuity of their adversary, and the challenge of deciphering its myriad components instilled both a sense of urgency and reverence. This was not merely a mechanical puzzle. It was a glimpse into the mind of a foe who had so successfully leveraged technology and tactics to dominate the Pacific theater. The Zero was not just an aircraft, it was a product of a nation that had rapidly modernized, and the more the mechanics dissected it, the more they began to understand the cultural ethos embedded within its design. The engineers quickly noted the aircraft's aerodynamic efficiency, represented in its sleek lines and lightweight construction. As they compared it to their own fighters, such as the F-4F Wildcat, the differences in philosophy became stark. The Zero's design prioritized speed and agility at the expense of armor, reflecting Japan's own tactical doctrine that emphasized maneuverability over brute strength. This obsession with weight reduction, utilized in the minimalist frames and the innovative use of materials, further illustrated a national narrative shaped by necessity and innovation. The mechanics began to see not just an enemy aircraft, but a national identity, meticulously crafted and honed through years of conflict and competition. Amidst the mechanical dissection, one detail surprised them: the use of a unique type of aluminum alloy that was lighter than any other they had encountered. Its origins were a closely guarded secret, symbolizing Japan's industrial prowess and their ability to exploit resources effectively. It became clear that this material was not merely a component, but a representation of strategic foresight, one that allowed for speed and agility without sacrificing performance. The mechanics whispered about the implications of such advancements, pondering how these materials could shift the balance of air combat if replicated. This discovery alone justified the costs of the operation, sparking an insatiable desire for knowledge that permeated the workshop. As the workday blended into twilight, conversations shifted from technical specifics to broader reflections on the war. The Zero's design served as a canvas upon which the American mechanics projected their hopes and fears. They were fighting a war against an ideology, yet here they were, face to face with a manifestation of their enemy's resolve. Some mechanics voiced a growing admiration for the aircraft's engineering, recognizing it as a formidable achievement that demanded respect. The duality of their emotions was palpable. They were tasked with dismantling a lethal machine while simultaneously acknowledging the skill and creativity that birthed it. Night fell, and the mechanics convened around a makeshift table, their coffee steaming in the chilled air. They turned the conversation towards the war's broader implications, noting how both nations had progressed from isolation to industrial giants almost overnight. The specter of a protracted conflict loomed over them, yet the act of studying the Zero offered a modicum of hope. Understanding the enemy was not just an act of disassembly, it was a means to foster resilience and adaptability in American aviation. The mechanics understood, in a profound way, that the war was as much about learning and evolving as it was about combat. With each passing day, the disassembly process revealed not only the technical capabilities of the Zero, but also the glaring weaknesses that lay hidden beneath its polished exterior. The mechanics identified design flaws that hinted at corners cut in the name of speed. Some components exhibited signs of hasty assembly, suggesting a rushed production cycle that might compromise long-term durability. This revelation ignited conversations about the difference between perceived invincibility and the reality of engineering limitations, underscoring an essential truth. Even the mightiest of foes can falter, and overconfidence is often a precursor to failure. As the mechanics continued their meticulous work, they encountered a particularly curious feature: a complex system of controls that allowed for exceptional pilot maneuverability. Several mechanics speculated on the psychological implications of such design, reflecting a belief that a pilot should feel almost as one with the aircraft, an extension of their own body rather than a mere machine. This sense of unity resonated deeply with the American mechanics, who understood that the artistry of aerial combat was not only technical but also psychological. They began to appreciate that the Zero's design mirrored Japanese martial traditions that prioritized equilibrium and harmony, further complicating their understanding of the conflict at hand. Finally, as components were catalogued and studied, the mechanics stumbled upon a document tucked away in the pilot's manual, a list of suggested improvements and modifications penned by a hapless engineer who had evidently poured his heart into the pursuit of perfection. This poignant discovery struck a chord. It encapsulated the human element behind the machinery and the shared struggles of all those involved in the war effort. The careful handwriting and the earnest notes served as a reminder of the shared humanity that existed even amidst the chaos of conflict. In that moment, the mechanics realized that they were not just dismantling an aircraft, they were unraveling the intertwined fates of two nations, both striving to assert their distinct identities in a world at war. As the American mechanics meticulously disassembled the remains of the Japanese Zero, the reality of their endeavor began to set in. Each panel and component revealed not just the craftsmanship of Japanese aviation engineers, but also the tenacity of a nation at war. The team, stationed at a hastily assembled workshop near Pearl Harbor, was acutely aware that every piece they examined could reveal crucial information about their enemy's capabilities. The Zero, designed for air superiority, showcased advanced aerodynamic principles that had eluded American engineers until then. As they laid out the parts, the mechanics exchanged glances that spoke volumes. This was not just salvaging wreckage, but peeling back layers of an adversary's identity. In the heart of the aircraft, they uncovered a hidden compartment that had been overlooked in the initial assessments. Curiosity piqued. They pried it open to reveal what appeared to be a series of handwritten notes, meticulously organized and neatly folded. The notes, written in Japanese script, contained diagrams and calculations that seemed to detail various flight techniques and aerial maneuvers specific to the Zero's design. This unforeseen find indicated that the Japanese had been refining their tactics even while engaged in combat, a revelation that sent ripples through the team. It became clear that the Zero was not merely a product of engineering prowess, but also a testament to a strategic mindset, keen on adapting and overcoming obstacles in real time. The implications of their discovery were profound. Each note represented an effort to maintain the upper hand in dogfights that had already claimed numerous American pilots. The mechanics knew they were holding a key to understanding their opponents better, but the gravity of the situation weighed heavily on them. Many had friends and loved ones fighting in the Pacific, and the notion that their adversaries were not just reacting but actively innovating filled them with a sense of urgency. The notes became a symbol of the broader conflict, a war not just of weapons, but of wits and will. Every calculation hinted at a deeper understanding of aerial combat that would soon necessitate a reconsideration of American strategies. As they continued their work, the mechanics found themselves enveloped in discussions about tactics. The Zero's design emphasized a lightweight frame and exceptional maneuverability, characteristics that American fighters lacked. One mechanic, Thomas Hargrove, a former pilot himself, suggested that they should analyze the newfound notes alongside their own flight experiences. It was an attempt to bridge the gap between two different philosophies of warfare. One focused on brute power and the other on agility and precision. To Hargrove, the very act of adapting to the Zero's strengths was an embodiment of American resilience and ingenuity. He envisioned changes that could transform their existing warplanes into more effective fighting machines. Meanwhile, the atmosphere within the workshop took on an air of camaraderie as the shared goal of defeating their foes forged deeper bonds among the men. They were not just mechanics anymore, they were participants in a grand narrative of survival and triumph. There was an unspoken understanding that their work could turn the tide of the air war against Japan. Each day spent studying the Zero became a testament to their determination, a metaphor for the sacrifices made by soldiers on the front lines. The aircraft became more than a relic of defeat. It was a catalyst for change that galvanized the spirit of the American workforce. This newfound sense of purpose was juxtaposed against the larger realities of the war. As reports continued to filter back from the Pacific theater, the toll of the ongoing conflict weighed heavily on the country. Each lost pilot, each failed mission, echoed across shores and across families. The mechanics, in their pursuit of knowledge, were acutely aware that they were also bearing the hopes of a nation. The Zero resonated with symbols of struggle and resilience, a reminder of the price of underestimating an adversary. The notes they studied weren't just technical specifications. They embodied the heart and soul of a nation at war. With each passing day, the mechanics' understanding of the Zero deepened. They began to make conceptual sketches of modifications that could enhance their aircraft's performance, inspired by the Japanese notes. It was an act of defiance, an embrace of innovation as a means to counteract adversity. They envisioned a new fighter that could rival the Zero's agility, a machine that would not only survive, but dominate the skies. Such aspirations were not born from blind hope, but from the desire to avenge the losses suffered by their comrades, an impetus that fueled their labor. As they worked late into the evenings, surrounded by the metallic scent of tools and oil, the mechanics found solace in their shared mission. Each piece of the Zero that they studied was a reminder of what they stood to protect. The aircraft, once a harbinger of defeat, transformed into an emblem of perseverance and innovation. The notes, filled with the meticulous calculations of an enemy, became a means to not only learn, but to rise above their current limitations. The narrative of war was shifting, and in that workshop, the mechanics became unlikely authors of a new chapter, one forged by adversity and perseverance amidst the raging conflict that enveloped them. In the aftermath of the grueling battles of the Pacific Theater, American mechanics gathered in the dimly lit hangars of Pearl Harbor, each driven by a singular purpose: to decode the mysteries of the Japanese Zero. Among them was Corporal Jack Reynolds, who, having spent his childhood engrossed in the mechanics of bicycles and automobiles, found himself thrust into the role of a war technician. The Zero, with its elegant lines and unnerving agility, was both a marvel and a menace. The aircraft embodied the spirit of Japanese engineering, which had achieved remarkable advancements under duress. Yet, as Reynolds and his fellow mechanics began the meticulous task of disassembly, they were unprepared for the layers of complexity that awaited them. As they removed panel after panel, the mysteries of the Zero unfolded like pages of a long-lost manuscript. The aircraft's construction revealed the ingenuity of its designers, who had employed a lightweight aluminum alloy, a material that was both a boon and a bane. It allowed the Zero to soar with unmatched speed, but also rendered it vulnerable against heavy gunfire. The mechanics noted the contradiction. This was a fighter designed for dominance in speed, yet its very design left it perilously fragile. Each piece they uncovered hinted at a philosophy that championed agility and maneuverability over sheer robustness, a testament to a belief more profound than mere engineering, the idea that victory lay in evasion rather than confrontation. Reynolds and his team found themselves captivated by the fuel system, a labyrinthine network of pipes and pumps that reflected the meticulous attention to detail typical of Japanese craftsmanship. They discovered a baffling feature, a series of redundant systems designed to prevent fuel starvation during extreme maneuvers. This was not merely an engineering choice, it was a reflection of a cultural ethos that valued precision and foresight. The mechanics, coming from a society that often prioritized brute strength, began to appreciate the subtleties of a philosophy that embraced finesse. The Zero was not just an aircraft, it was a symbol of Japan's resolve to innovate under pressure, an embodiment of how necessity could breed invention. As the days turned into weeks, whispers began to circulate among the mechanics about the Zero's performance in combat. Pilots who had faced the aircraft in the skies spoke of its uncanny ability to outmaneuver even the best American fighters. Yet here, on the tarmac, as Reynolds and his peers roamed the inner sanctum of the aircraft, it became apparent that superiority was not solely based on technology. The Zero was an expression of a national identity forged in the crucible of adversity, a poignant reminder that in war, psychological factors often determined outcomes as much as mechanical superiority. The mechanics, all too aware of their own nation's struggles, began to see a reflection of their own ethos in the struggle of the Zero. Then came the moment that would forever alter the course of their understanding. Hidden within the structure of the aircraft, concealed beneath layers of aluminum and fabric, the American mechanics unearthed a startling element, a handwritten log detailing modifications and adjustments made throughout the Zero's production. The entries were meticulous, chronicling flight tests, adjustments to balance, and even responses to combat conditions. This log was not merely a manual, it was a narrative of innovation, revealing a relentless pursuit of excellence. As they pored over the meticulously crafted notes, Reynolds felt a shiver of recognition. This was a testament to human ingenuity, a reminder that ingenuity can emerge from desperation. With each page they turned, a deeper understanding emerged, not just of the aircraft, but of the spirit of those who built it. The log was inscribed with a cadence that echoed the struggles faced by the American mechanics themselves. Each note captured a moment of doubt, transformed into resolve, a passing of trials into triumphs. The collective experience was not limited to national borders. It transcended them, forming a bridge of understanding between two nations locked in conflict. For Reynolds and his comrades, the Zero became more than an enemy aircraft. It transformed into a symbol of the shared pursuit of excellence amidst chaos. But as the mechanics continued their work, the implications of their discoveries weighed heavily on their hearts. They recognized that understanding the Zero was tantamount to understanding their adversary. This delicate dance between rivalry and respect kindled a complex spectrum of emotions within them, forcing them to confront the harsh reality of war. The revelation that the pilots and engineers on the other side were not merely faceless foes, but skilled craftsmen with their own dreams and aspirations, sowed seeds of contemplation about the nature of conflict itself. Reynolds realized that despite the enmity, a common thread of humanity existed, binding them in ways that transcended national identities. As the mechanics compiled their findings, they knew that the intelligence gained would influence future engagements in the Pacific. The American military would adapt strategies based on their insights, but more importantly, they would carry forward a newfound respect for the artistry of their opponents. The Zero became a case study of both engineering and the human spirit, a dual legacy that reshaped how American forces would approach air combat. Reynolds, looking at the battered remains of the Zero, understood that in disassembling the aircraft, they had unwittingly begun to dismantle the barriers of hatred that defined the war. Ultimately, this moment of discovery in the hangar at Pearl Harbor transcended the mechanics' immediate mission. It initiated a silent dialogue that would resonate far beyond 1942, laying the groundwork for future engagements. The Zero, with its intricate design and underlying ethos, would serve as a reminder to all who encountered it that war, despite its destructive nature, could also be a catalyst for understanding. Through the careful disassembly of this formidable aircraft, American mechanics not only uncovered secrets of engineering, but also unearthed an impossible truth, that amid the chaos of conflict, the potential for enlightenment and connection persists, waiting to be realized. As we examine the profound implications of American mechanics dismantling the Japanese Zero in 1942, we are reminded of the intricate tapestry that makes up wartime innovation and conflict. This moment serves as a testament to human ingenuity and the relentless pursuit of knowledge, often emerging from the crucible of adversity. The discovery of the Zero's remarkable engineering not only shifted the balance of air combat, but also highlighted the blurred lines between enemy and ally in a world driven by survival and urgency. In the aftermath of such revelations, we bear the responsibility to honor those who toiled in workshops, transforming technological marvels into instruments of warfare, while also recognizing the broader implications for humanity. This episode urges us to reflect on our past decisions and their enduring consequences as the lessons learned during this turbulent era continue to resonate in today's geopolitical landscape. As we navigate contemporary challenges, we are called to acknowledge the legacies of innovation born from conflict and to strive for a future where understanding and collaboration prevail over division and discord. History, as this narrative illustrates, is not just a record of events, but a mirror reflecting our shared humanity and the choices that define us.